Okay, in this video, I just want to talk about the difference between mutually exclusive and independent events. These are two words that quite often get confused, so I want to make sure we draw a distinction between them. Mutually exclusive. Two events are mutually exclusive if they have no outcomes in common. Okay, so if I give you two events and none of their outcomes are overlapping, we call it, then they're mutually exclusive. So for instance, the best way is to look at an example. Drawing the jack of spades or a heart. There's no way that you can draw a jack of spades and a heart at the same time. The jack of spades is not a heart. So those two events are mutually exclusive. Another one is rolling a die, which is a good example. So if you want to find the probability of throwing a 2 or a 6, it's impossible to throw a 2 and a 6 at the same time. Those two events are mutually exclusive. All right. If two events are mutually exclusive, then we have a formula for finding their probability. Probability of A or B, if they're mutually exclusive, is just the sum of their probabilities. So if I look at the probability of drawing a jack of spades or a heart, we'll call this probability of A being the spade, or well, actually we'll call that the jack of spades, event A. We'll call the heart, event B. So the probability of A, well, that's just 1 out of 52. 52 total cards, 1 jack of spades. Probability of event B, that's 13 out of 52. 13 hearts out of total 52 cards. So if you sum these up, you get 14 out of 52, and you can reduce that if you want to 7 out of 26. Or the decimal would be fine too, but that's the probability of drawing the jack of spades or a heart. Okay, mutually exclusive events. Let's look at the probability if events aren't mutually exclusive. That will happen sometimes too. So consider this example. In a hospital, there are 8 nurses and 5 physicians. 7 nurses are female. 3 physicians are female. If we're going to pick a staff person randomly, we want to know the probability that the subject is a nurse or a male. You see the issue here is that it's possible to be a nurse and a male. Okay, so here's what we are going to do. We're going to draw a Venn diagram first. Okay, we're going to look at the number of nurses and then the number of males. Okay, so here's our Venn diagram. How many nurses are there? Well, there are a total of 8 nurses, but look, 7 are female. So we got 1, 2, 3, 4, 5, 6, 7 female nurses, 1 male nurse. That's going to be in the overlapping area there. Okay. How many males are there? Well, there's 1 male nurse and 2 male physicians. So there's 3 males total. But we've already got this one here in the middle of the Venn diagram. Okay. So that's what is kind of representing the situation. So if we want to find the probability, what we would do is we take the number of nurses there are 7. Sorry, 8. Excuse me. There are 8 total nurses. How many males are there? Well, there are 3 males. All right, but how many nurses are also male? Well, there's 1, so we subtract 1. That's all divided by the total number of people there are, which is 13 total people. Okay, so the probability of A or B, I guess we should have labeled A or B. We'll call a nurse event A. We'll call being a male event B. Okay, so the probability of A or B happening is 8 plus 3, which is 11 minus 1, so 10 out of 13. Okay, so that's what happens when you're not mutually exclusive. Okay, the two events, you can be a nurse and a male. Okay, let's look at the very last thing here, which is independent events. Two events are independent if the fact that A occurs does not affect the probability of B occurring. Okay, so independent means that one event has no effect on the other. They could both happen at the same time, but that doesn't mean that they affect each other. Okay, so like rolling a dice and getting a 3, and then rolling a dice and getting a 6. So the rolling of the 3 has no effect on whether you roll a 6 on the next roll. Okay, so those events are independent. Other examples, rolling a die and drawing a club, or rolling a 6 on a die and drawing a club. Those events are independent of each other. If you roll a 6 on the die, it has nothing to do with whether you draw a club or not. Okay, so those are independent events where they have no effect on each other. So let's look at this example here. The probability of winning a game is 0.1. What is the probability of winning the game both times if you play twice? Okay, well, here's what happens if we've got independent events. If you want to find the probability of an independent event happening and another independent event happening, you just multiply the probabilities. So what's the probability of winning once? So we'll write this down here. We'll try to write. Okay, what's the probability of of winning the first game. That's 0.1. Okay, well that's cool. What's the probability of winning the second game? 0.1. Right? Those events have no, you winning the first game has no effect on the second game. So your probability of winning the first is 0.1, probability of winning the second one, 0.1. What if we want to know the probability of winning both the first and the second? Now you got to multiply the probabilities. What does that give you? Well, this is, if you think about it, a tenth times a tenth, which would be 1 over 100, which is 0.01. Okay, and if you were to convert that to a percent, that'd be 1%. Okay, so that's how we handle independent events, or probabilities of any independent events. We multiply them. So take some time, really maybe rewatch the video. You want to really understand what the difference between mutually exclusive is and independent, so that you don't confuse them. There's also a good diagram in your book as well that outlines the differences.